don't hesitate and please, you can every time hold your hand. Maybe you know this button on the reaction sign in Teams, so you can hold your hand. It looks like I don't know. This is the button with the reaction. I think reaction sign. Yeah, that one. So if there, then I will answer your questions, or if there's something unclear, so then you can also inform me anytime here. Yeah. Okay. So also, if I have some scripts to share, I will do it here in this Teams and do it in the Teams folders, so that you have all scripts and protocols or something that you need for this training, or that we have in this training. I will share it in the Teams. Okay? Ja. Naja, aber dann tust du es am besten weg. Also. Ja. So. And also one question, is it planned that you come in future here to the training?
End of this month, I believe we'll be back down there in Garrett Street.
Okay. When will it start?
The 23rd, I think. Monday, 23rd.
The 23rd.
Okay, 2 weeks. In two weeks, I think, huh?
Yes.
So all of you are?
Just some of us from this group.
Okay. Yeah. Yeah, and not bad. So, but I know in my plans, that's unfortunately, I'm not your trainer but I don't know how it, sometimes things change very quick, and I hope I can see you live here at our trainings academy in Pfronten. Okay, then we will start with the first thing. So can you see the screen?
Yes.
Yeah, okay. So we will talk first about physical facts, I think. So machine conditions. So a lot of things can have an influence for our machine geometric. So I think, you are mostly experienced guys for machining, and also I think you know that things that can have an influence. So, but a lot of things I have to explain in this training, because it's one step of it. So then we start machine influence about airflow that can happen if you have machines near doors or windows that are open, or something else, that you have a bad results at the machines. Second thing is a big thing. This is a temperature that have a big influence. I know it from my experience, especially at the EMG machines here from Pfronten. There are some have a big influence, because when we look at the screen, I take this mouse is better. So there you see a naked dual block machine. So that's naked dual block machine with a B-axis. So I think everybody know the coordination cross in that way. And our machines here in Pfronten, they are mostly, I think 90% will be delivered with 3 points settlement. So we have 3 shoes in a 3-angle direction, and that's the 3 points where our machines stand on the floor foundation on any event. So, and if you can imagine, if I have an airflow here underneath, or I have a big temperature difference, maybe from the morning to noon, or from noon to the evening. So these machines can grow, or yeah, anyways, they can have a big influence of our geometric here. So we see in that way we have a table. That's our C-axis, and we have a machine bed. On the bed we have, in that case, dual block Y-axis. Then we have we call it tower. So we have a tower or a sleigh, tower and sleigh. On the tower we have 3 times a X-axis, and for the sleigh we have a Z-axis sleigh, we call it Z-axis sleigh. And there is the round axis B-axis available. So that's the 5 axes here at the dual block machine. So in that case, when you can imagine if we have here temperature influence. So one question to you, what do you think how we can handle temperature influence for that machine?
Cooling circuits in the casting, the rails, ball screw, all that stuff.
Yeah, that's right. And also, yeah, in the past when I was out 20 years ago, there was no cooling in the ball screws, and also we have no cooling under the rails and stuff. If you have no cooling, what do you think we can handle temperature problems?
You got that compensation table and all that, right?
That's the truth, yeah. So that is the big thing that we use in every machine. We have compensation tables. We have also tables for mechanical things, and also we have a compensation table for the scales. And that's a lot of things that we have an influence, or not influence, I will say. There's a lot of things that we can fix or bring the machine to correct movement in a good tolerance ways. So if we see that machine, I will go a little bit more. What's another big point is, this coordination cross, this I think you know it. Maybe I have one. So we have a little helping tool here for the coordination cross. So if you come to Pfronten, I will give you one, or my colleagues. So that's a big helping tool for us. And I think for everybody who have to fix some machines or measurement, so that they understand which axis moves around the other axis. So that is in the Pfronten or in the DMG 5-axis machines always the same. So we know the Z-axis, that axis will be changed sometimes. Maybe you have a horizontal machine, but if we have a look of the dual block, we have the Z-axis is the vertical axis, and the X-axis is the square axis. Square. So the y-axis is the horizontal axis in that case. So, and then when we look, if you look at the screen, we see the b-axis moves around the y-axis, and that's always the same. If we change the coordination cross, that the z-axis will be the horizontal axis, then also the y-axis will be changed with the b-axis, and also the c-axis will always turn around the z-axis. So if we turn it to horizontal, then we have a c-axis movement in the horizontal axis. So if we change the cross, so the c-axis will be turning around that's always the same. This axis goes with the basic axis. So round axis goes with the vertical axis or the straight axis. That is a big thing if you measure machine, that you know that, and also especially if you have adjustment later on with kinematics, that you have to know which axis moves around the other axis. So if I go a little bit down in my screen, take this mouse, that's better. In that case, we see a dual block machine with an A-axis. So this machine is very rare. I think we built only 5 in a year, so not so much. The mostly, so 95% in the dual block series, I think we will deliver out with an B-axis, but we have machines also with an A-axis. And then in that case, the 5-axis will be changed. So we have the second round axis turns around the X. And also if you see it in the camera, so this will be the A-axis, which will turn on the X-axis. Okay. Another point that we will go in this training, this is always we have to know the machine's 0 point. So there's also a thing that we have later on, especially to know for kinematic, and also if you have to change some scales or something else, then you have to know where is the 0 point from my machine. So that 0 point can be different. So we have here, at that picture, we have a monoblock machine. So there is a, I call it a virtual 0 point. It's at the end of the machine anywhere. So and from that one, that is the machine 0 point. And don't convert it with the reference point. The reference point is a point from the scales. So for your tail measuring system. So that's that's the difference about that points, 0 points. So we have a machine 0 point and we have a reference point.
Werkzeug, das Tool.
So then we will start for the training at today. So I have to do it. I think a lot of guys, for you maybe it's also a little bit boring because you know that. But anyway, who's not know it? So please take your time. So I see that way. I think you use a lot of that equipment for measuring something. So we have a lever gauge, and in that case, you can do some measuring failures. So because you have to always look that the lever gauge is parallel to the measuring basic. So for the workpiece or the surface that you have to measure. So if you don't have the access that you have do it right parallel, then you have to measure there and correct it with an factor. So you have to look for an angle. How is it called? Direction angle. And if you cannot be with an angle, you have to calculate it with a factor, and that is described. So for that case, I will show you a short film. Here are the corrections angle. So if you have an angle not parallel, so you have 10 degrees lever gauge to the surface, the correction factor is 0.98. Was war das? Yeah. And the tables will be sent out whatever dealer gauge, dial gauge that you have. So just a moment, I will share a little film. In that we can see the failures about the measurement with that dial gauge. So, Unterlagen, oh, das ist der erste. Was? Aber stop. So just a moment. I bring the film in the screen. Can you see the film picture?
Yeah.
Okay. So sorry for that. This is in German, but I will also translate something about it. So how you so in that case we have a two stiff angle, and there was 6 microns failure in. Now it's parallel, and now is the value around 2 microns. So that's a thing. So that foil has 0.5 millimeters and shown is 0.80. So we have 30 millimeters, 0.30 millimeters failure. So is it near to parallel, then we can reach the right value from the foil. So here you can see they do the same steps in the values, but you can see the different. So the right one, we see there is a too stiff angle, and that can have you bring you the wrong values. If you go into parallel, yeah, so that is a explanation for failures if you have parts like that. And if you look all the time, is it parallel? Is your equipment, your measurement equipment parallel? Then you have also right values in the measurements. But I think, did you use the Mosting, the lever gauge, or did you use dial gauges like that one?
Mainly the lever gauge.
Mainly the lever gauge. So that, for the explanation, please be careful for the angles that you have to measure. This one example. So if you use dial gauges like that, yeah, it's nearly the weight is a little bit bigger, and what can happen if the weight of the dial gauge is bigger, or is what can happen if you have dial gauges and you have to turn the measurements or something. So that's, we have another big influence for measurement, and we call it, that's the sag. So if you have to do some measurements on every machines, you can imagine your complete picture measurement equipment is, if you have to turn it, you have an influence of sag. And there also I will show you some short movie for sag, I think there, or gravity, I call it gravity. So now we can see here in the left side dial gauge picture, and only the gravity you see on the big picture, how much influence it has. So you see, we here around, from the first beginning, the axis was moving, I think, to plus 90 degrees. And now we come to the start position. Yeah. So in that case, you see how much influence you have only from the weight or the gravity from the complete picture that you can do. And that's to talk about some measurement failures that you can have. And if you have bad measurement failures, you have bad results, and you have also bad workpiece and frustrated customers and something else. So that is one thing I have to explain you that can happen for measurement failures. So okay, I think we do a 10-minute coffee break. Is it okay for you? Sure. So then we met us in 10 minutes. Then you can have a look later in 2 weeks or 3 weeks or anyone, anytime. Muss ich nur teilen. We'll share. So was war da noch? Chat, oder? Okay. Yeah. Wieso kommt da nichts? Ah, da kommt's. Yeah. First picture with the some dial gauges that we use, and also end blocks. Here we see a test manual, so that's available in different tool pickup tool systems, SK, HSK, Cacto, something else what's available. And also in that case we have a test bar. So that is one thing we use here at the Pfronten plant. So every machine here in Pfronten will do the geometric basics with that tool for that equipment.
Was that a test bar that you mount on the table? Is that what that is?
Yeah, that I will go back just a moment. That one is a test bar. We see it here. We have some piece of metal that you can, if you lay it down, we have it in the T-slots. In the table, in the round table, you can fix it in the T-slots, and that way. Or if you have it, do it vertical, then we have underneath two magnets that it is fixed on the table. Okay? So later on, and also tomorrow, you will see that we will use it here in our training. It's a little bit what is measuring. I think everybody from you knows what is measuring. I will not go deeper in that way. So what are measuring equipment and how are they used? Also, you see it when we do some practice tomorrow. Then we can bring some examples how we do it. But also, if you experienced guys, you have your own way. But I think one thing is very important to do or to know. You have to do the reversal measurement, so that if you have in every measurement you will do with that tools, you can bring errors and failures. The fixture is not stiff enough. The dial gauge is maybe damaged, or something else have influence of your measurement fixtures. So that to be ruled out, make a reversal measurement. So that's one big point that I can recommend you, that you are being safe how to use it. So, and how are the results evaluated? That's also one point we go. Yeah, target is that you know to use indicators, measurements, frames, anything to measure on our machines here, especially duo block. So how you can carry out measurements and also measure in angles and know the basics, what we have to measure. And also, maybe, I don't know if we can do it this day, that we do the test manual, but I think tomorrow we will do it with the test manual. Okay. So, definitions is show, okay. Yeah, measurement is a comparison of known unit with a quantity to be measured unknown.